Question 6 was about the use of the LDR in a light sensing circuit, and in fact the first mark was for identifying that it was an LDR. So you need to learn your circuit symbols, no way around that, and know that that one is an LDR or a light dependent resistor. Either was fine for 6A part 1, where it says what is component X in this circuit diagram. And it shows you the graph of light intensity versus resistance. This unit of lux here you're not expected to know. That is just a unit of light intensity. But very important to note that this graph is resistance in kilo ohms, so that is thousands of ohms. That's going to cause you problems if you don't notice it later on. So the next part after what is the component is use the graph to find the resistance of component X when the light intensity is 20 lux. Well, you just go to the 20 lux mark on the graph, up and across, and it will be 25. You don't lose a mark here for not putting the units. That's why the kilo ohms is in brackets. They punish that later on. Okay, so 25 is fine. And there's a range. There's always a range when you're reading off a graph like this. You're allowed 24 to 26. Okay. Right, 6A part 3 is another calculation question. When the light intensity is 20 lux, the current through the circuit is 0.0002 amps. Lots of zeros there, easy to get mixed up about the number of them, or just put them into your calculator wrong, so be careful when you see that. Use the equation in the box to calculate the reading on the voltmeter when the light intensity is 20 lux. Now, some people here just threw the two numbers that were available into the equation and did whatever. Okay, we are trying to calculate the potential difference, because remember, voltage and potential difference are pretty much the same thing. So we are going to multiply two things together, but we need to make sure we're multiplying current and resistance. The current is given to us directly in the question, but the resistance is not. The question gives us the light intensity, so we need to use the graph again. It's been really nice to you and asked you in the previous part, what is the resistance when the light intensity is 20 lux? So all you need to do is to substitute your answer, the 25 kilo ohms, into the equation. And here is where they are punishing not realising it was kilo ohms. So if you look at the mark scheme, it says allow 1 mark for converting 25 kilo ohms. In other words, to make that 25,000, not just 25. Okay. If you happen to read the wrong value off the graph, provided your substitution is correct, you get 1 mark in this part here as well. Okay, and you also you do get the second mark for that, provided your calculation is correct. So you can get both the marks here, even if you've read the wrong value off the graph, provided your final answer agrees with whatever reading you've put in 6A part 2. Okay. So 1 mark for converting to 25 kilo ohms, so 25,000 ohms, and a second mark for the rest of the calculation, basically. Now, the second half of this question was generally much trickier, and you've got to be really careful. It says, first of all, use the grid below to show how the voltmeter reading in the light sensing circuit varies with the light intensity. Add a suitable scale to the y-axis. Now, you had to have in your scale, it had to cover the correct range. Okay? It says using all of the available axes, so you need to make sure you've got all of it labelled. It must cover the range 4 to 6 volts, or your answer to A part 3, so whatever your voltmeter reading was here, okay, up to 6 volts, and the maximum range you're allowed is 0 to 15. So if you went 0 to 20, you didn't get the mark. 0 to 15 was the biggest range you were allowed, and you would have got the mark if you'd gone from 4 to 6. That would also be fine. And then it says, complete a sketch graph by drawing a line on the grid to show how the voltmeter reading will vary with light intensity. So we can't just do this straight away. We need to go back to the diagram and think about how the voltmeter reading is going to vary with light intensity. So, you need to remember that the bigger the resistance of a component is, the more voltage will drop across it. Okay, in a series circuit. The current around this circuit is going to be the same all the way around because it's series, and that means that a larger voltage will drop across the higher resistance component. So, it's asking us what will happen. If we go back down here, complete the sketch graph with drawing a line to show how the voltmeter reading will vary with light intensity. So, if we imagine starting at 0 lux light intensity, we have an extremely high resistance. Okay, you can't really read it off the graph, but it looks like it's going to be very, very, very large. We don't know what the value of that fixed resistor is, okay, but we do know that no matter what the value of that fixed resistor is, the voltmeter reading in volts is going to be extremely high, as high as it can be for this component when its resistance is very high. Now, very important to realise that the maximum reading you're ever going to get is 6 volts. You can't drop more volts than the battery supplies. Okay, so pretty much this first part of this graph here for 0 lux is going to need to start at 6 volts. And you also need the other, so that's one mark, and it needs to be a negative gradient line, right? Starts at the highest voltage here and it decreases, and the other mark is for making sure that your answer passes through 20 lux and your answer to A part 3 here. Okay, so you've worked out one of the points on this graph in the previous part of the question. Again, it's leading you through it. You need to make sure that when you plot your sketch graph, your line goes through that point, so it should go through 5 volts at 20 lux. So you should go from 6 down to 5, and it doesn't really matter what you do with the rest of the graph provided you have a negative gradient line. It doesn't really matter if it's straight or not. You don't really know that. You could work out some other points, but in fact that is going to be very difficult because you don't know the current. So you can't work it out. You just have to use the 2 points that you do know. Okay? So you only got the mark for passing through the second point correctly if your line does not go above 6 volts. If your scale went from 0 to 8, say, and at any point your line goes above the 6 volt mark to 7 or 8, you don't get that second mark. So that second mark is really hard to get. 6c, the following passage is taken from the technical data supplied for component X by the manufacturer. For any given light intensity, the resistance of this component can vary by plus or minus 50% of the value shown on the graph of light intensity. Calculate the maximum resistance the component X could have at 20 lux. Well, again, you just need to take your value that you've read off the graph here for the resistance at 20 lux and add 50%. So that's multiplying it by 1.5. Okay? And if you've got the correct 25 kilo ohm value, that gives you 37.5, because half of 25 is 12.5. That's the extra 50%. Add it on to your original 25, and that gives you 37.5. Again, you got credit for if you've read off the graph incorrectly and you add 50% onto that value, you get the mark here. Okay, so you get the error carried forward mark. And finally, explain why this light sensing circuit would not be used to measure values of light intensity. Well, lots of answers here were as if you hadn't read this at all. If there's a 50% variation in the resistance, let's look at what that does on the graph. Okay, so let's look at our 25 kilo ohms. If that resistance varies by 50%, then you can see up to the 37.5 mark, the light intensity range that you're going to get is sort of almost anywhere between nearly 10 lux and 30 lux. That is not very precise. So its precision will be rubbish, okay, because of that variation of plus or minus 50%. So you wouldn't use it in principle because it's not accurate enough, or the results would be unreliable.